everyone. Welcome to today's class. Today we will continue to talk about R basics, and then we will talk about R Markdown. I'll talk about how to start R Markdown file, how to insert code chunks, how to insert links, images, and how to write in R Markdown, and finally generate a report using R Markdown. Okay? And then if we still have time, we'll start to talk about R programming. Ideally, we should use 2 lectures to talk about R programming because there are a lot of components in that topic. However, we might not be able to finish everything in that topic because we only have about 1 lecture. So hopefully we can cover as much as possible. Okay. All right, let's continue to talk about data structures in R. Last time we talked about vectors and matrices. Okay. Vectors are one-dimensional arrays, right? And the elements should have the same data type. And matrices are 2-dimensional arrays, and also elements should have the same data type still. Okay. And we can create matrices using different functions. We can create a matrix from a one-dimensional vector, okay, by changing the dimension. We can also use the matrix function to, example, let me briefly review. We can create a matrix from a vector, right, by changing the dimension of it, right? Changing the dimension of it. We can also create a matrix using the matrix function. And we can add column names and row names. We can also create matrices from column vectors or row vectors using the cbind and rbind functions. And the cbind function and rbind function can be used to add additional columns or rows. So you can combine a matrix with additional columns or rows. So there are many ways to create a matrix. Then let's move on to lists, the third type of data structure in R. So a list is a combination of objects. So it's one-dimensional. And the objects in a list may or may not have the same data type. So it's very flexible. It can have the same data type, but it's not required. And the elements in a list may have different data shapes. So for example, let's create a list. First, we create the components of the list. X is a single value, or we can say it's a vector of 1 value. And LV is a letter vector with 5 elements. M is a matrix, a 3x3 matrix. We can combine them together to create a list. Okay. You just need to use the list function, put them together. And then if we print list L, you'll see it's like this. It's in concept one-dimensional still. It has a length, right, 3 components. And each component can contain values with different data types and different data shapes. So it's super flexible. Right. How to extract elements from a list? 2 ways. One way is to use single square brackets, right? L2. Then this is kind of like list slicing. You will get the second component of L. It's kind of like a sublist. Alternatively, you can use double square brackets. Then you can refer to the specific elements of the second component of L. Let's see but they are not the same, but they are similar. You can usually we use double brackets. The last data type is data frames. Oh, by the way, in R, most of the outputs of R functions are lists. It has different components. For example, the regression function LM function, if you run that data regression model, the output is a list. It has the regression function and the coefficient table and some additional statistics, for example, R squared, adjusted R squared, etc. So each component is part of the list, and anyway, the output is always a list for all the functions. Then let's move on to the last data structure, data frames. So this is the most commonly used data structures in R, and in other statistics packages, they are called data matrices or data sets. In R, they are called data frames. So it is a list of vectors of the same length that are related across. So if you consider each column in the data frame as a vector, a column vector, and a list is somehow is similar to a matrix, data matrix, but the columns can be of different data types. Kind of difference. So let's see how to create a data frame. Last time we learned how to create a data vector using the C function, right? So now let's recreate these two columns, weight and height. And then you can use the data.frame function to create a data frame. So df, so this is a data frame. And components in a data frame can be accessed using the dollar notation, a dollar operator. So if there is a column name for the column, so alternatively, you can treat the data frame as a matrix. You can use the position, use square brackets. For example, if you want to pull out the second column, then use df brackets, comma 2. You get the same result. But this is kind of special for data frames. Only works for data frames. So this is how to extract components. Then let's see in general how to subset data structures. First, vectors. Vectors are one-dimensional, so you only need to specify one index. For example, we want to extract the second value in the vector. We can say weight 2, square bracket 2. We can also choose multiple elements. For example, we want to choose the first, the third, and the fifth elements. Then pay attention, you should not just put 1, 3, and 5 directly in the brackets. Instead, you need to wrap all of these indexes in a vector first, because these are all corresponding to the row index. So this is one-dimensional. So it is just it can only accept one object as the index when you subset a vector. Okay, so that is a point, sort of like that. So yeah, or you can extract the first 3 elements. Wait, this works. Matrices and data frames are 2-dimensional. So when you want to access components of them, you need to specify both the row and the column indexes. For example, if you want to select the first, the height of the first observation individual, basically this one, you can use position. You can use df1, 1. Yeah, similarly, if you want to find the weight of the third individual, you can use df 3, 2. And to choose a column or a row, yeah, you can use square brackets too, or it's two-dimensional. You need to leave a space for the other index. For example, if you want to choose the first row, then use df1, comma, yeah, empty. So you still need this comma, right? Because that means, because df is two-dimensional, you're supposed to provide two indexes, but since we will select all the columns, we leave it open, but still we need two indexes. And similarly, the first column and all rows, comma 1. And since df is a data frame, you can also use the $sign to get the first column, second column. You also can choose a subset of a data frame by specifying multiple rows and multiple columns at the same time. So the syntax is similar to matrices, but the only difference is if it's a data frame, then you can use a $operator. And many times it's very common to select rows based on some conditions, right? So this is called conditional selection. Using some comparison statement to choose rows, to filter rows that satisfy that condition or conditions. For example, if you want to select all of the observations such that the height is greater than 1.75 meters, then we can do this. Still use the square brackets to select rows. Just put the condition in the row index position. That is because this condition is used to select rows, not columns. So you need to put this condition in the row index. And the column index is still left open. So then we see this is the result. Only the individuals with height that is greater than 1.75 meters are selected. This is conditional selection. It's also possible to use multiple conditions to select rows. For example, we want to select individuals with height greater than or equal to greater than 1.75 and weight less than 80. Yeah, then you can use this AND operator to connect the two conditions. And this is the result. Okay. And two built-in functions in R that can be used to select the first few rows or the last few rows. The head function by default will select the first 6 rows of a data frame. So just apply head. Notice that I create a data frame. I create a matrix with 50 rows and 2 columns. First, generate 100 observations from standard normal and make it a matrix, 50 rows and 2 columns. Then I can use the head function to show the first 6 rows. And you have the option to show other numbers of rows. For example, 3 rows is possible. You just need to add one more argument. The tail function works in a similar way, but it will show the last few rows. By default, the last 6 rows. All right, next topic, definitions of set. So this is sort of related to data management and also probability and statistics. So I think since these functions are available, we should learn them and review the concepts. So first, some operations about sets. Complements. What is complements? The complement of an event A consists of all outcomes in the sample space that are not in A. So let me draw one diagram to review the concepts. Suppose this is a sample space. This is the event A. Then A complement contains all elements that are not in A, denoted by A to the C or A prime. Some textbooks use A prime. An intersection of two sets contains elements in both sets, common elements. So intersection, right? Denoted by A cap B or A and B. This is A complement or A prime. And the last one is union. The union of two sets consists outcomes that are in A or B or in both A and B. So 3 cases. Everything. But it will get rid of the overlapping elements. You don't want to keep one copy of the overlapping elements. So denoted by A cop B or A or B. So this is a very short review of the 3 operations for sets, complements, intersection, and union. Okay. And then R has functions that can help us to calculate these sets. So we first define a vector A with 5 numbers, and B also has 5 numbers. They have some common numbers. Then let's first calculate the union of A. Union of A will be like this. So see, 2 and 4 are in both A and B, but 2 and 4 won't be shown twice. There won't be repeated results or elements in the union. And intersection can be found using the intersect function. So the intersection, 2 and 4. And R has this function called set difference that can help us to find the difference between 2 sets. So set diffxy will calculate the elements that are in X but not in Y. In X but not in Y. Oops. So it's somehow like this. So suppose this is X, this is Y. So X minus Y, the set difference of X, Y will be this area, elements that are in X but not in Y. So consequently, we can use the set difference function to calculate the complemental event. Just start with the sample space, the whole sample space. Suppose the sample space is the set of consecutive numbers between 1 and 10, and A contains even numbers, and B is 1 to 5. Then A complement can be calculated as set difference as A. Right? So this is S minus A or B complement. Right? Similarly, B complement can be calculated use set difference as B. Right? And you actually can calculate the set difference between any 2 sets, right? No matter which one is larger, which one is smaller. Right? Just pay attention that this operation is not symmetric. From the definition, is pretty obvious. It's not symmetric. Set difference A, B will be A minus B. Right? So it will be like A minus the intersection of A and B. Set difference BA, denoted by B minus A, it will be B minus the intersection of A and B. They are essentially the same. Get rid of the common elements. So see, they are apparently different. the results are also different. So this is not a symmetric operation. All right. Any questions so far? Questions? I think many people are quite familiar with these topics, but I think it's good to review them still. Next is built-in distributions in R. So R has many probability functions. Actually, for any standard distribution in probability, there are a set of 4 items, 4 functions for that distribution. The 4 items are PDF or PMF, depends on the variable, the type of variable. If it is a continuous variable, then PDF, density function. If it is a discrete variable, then PMF, probability mass function. And the second function for that distribution will be the cumulative probability distribution function, CDF. The third one is the quantile function or the percentile function. And the last one is pseudo-random number generator for that distribution. So for any distribution, there are 4 functions associated with it. For example, normal. For normal distribution, there are D norm, P norm, Q norm, and R norm for these 2 functionalities. For T distribution, there are DT, PT, QT, and RT. So they are used to calculate PDF, CDF, quantile, and generate random numbers. Right? Pretty convenient to use. So let's just take a look at normal, some examples of normal distribution. Let's see how to use it. So in this example, I generated some equidistance numbers between -4 and 4 with jump point 1, call it x. The reason that I choose this sequence is because we know that standard normal distribution is very concentrated. Almost 100% of observations are in this region. Between -4 and 4. Actually, between -3 and 3, 99.7%, right? So this is a large enough region. Then we can create a line plot using the plot function. This is the x vector, and this is the y vector. Y vector is the PDF of x. So D norm x will calculate fx for standard normal. So that's why in the line plot, y is corresponding to fx, x is corresponding to the x values. And you see that the PDF for standard normal is a bell-shaped curve centered at 0, bell-shaped, very concentrated. And similarly, this D norm function actually accept some other arguments, which are the mean and standard deviation of the normal distribution. By default, the mean is 0. Standard deviation is 1. So that's why if you omit these 2 arguments, such that in the first panel, right, then we are evaluating fx for standard normal. But if the data is not normal, you have the option to specify the mean and standard deviation. And this is true for all of the functions in R, all of the probability functions in R. For the parameters for each distribution, for every parameter, there is a default value, which is usually corresponding to the standard case. But you also have the option to specify other values for the parameters. And if you put them in the right position, you don't need to specify the name of the arguments even. But if you're not sure, you should use their argument names, parameter names. So this is the density function, PDF. And CDF is used to calculate cumulative probability. So by definition, CDF is defined this way. Probability of X is less than or equal to little x, or Fx. For example, if we want to calculate probability of Z is less than -2, where Z is following a standard normal distribution, then in R is easy to calculate. Just call the p-norm function, p-norm -2. So this will calculate the cumulative probability. So it will calculate this area from 0 to 2. Right? Probability of Z is less than or equal to, oh sorry, -2. -2. This region. 0.02. So apparently R can be used to replace a normal table, any probability table that we usually use, because R can be used as a calculator and calculate these probabilities. And you can also calculate CDF for regular normal distributions. For example, suppose X follows normal with mean 100 and standard deviation 15. If we want to calculate probability of X is greater than 135, we can do this. 1 minus P norm 135, mean is 100, standard deviation is 15. Right. So this is because by default, the P norm function will evaluate left tail probability only. So it's calculating this. However, there is an argument that we can change so that it can evaluate the right tail probability. I think it is left tail or upper tail something. You can check the document. You can check it. Just type, if you have any question about the function, just type question mark in our console. And you see, oh yeah, the argument is called lower tail. So lower dot tail by default is true. So by default, it will calculate left tail probability. But if you set it to be false, then you can calculate upper tail probability. For example, in our example, if we slice 135, 135, 100 is the mean, 15 is the standard deviation, and lower dot tail, if we change it to be false, then it will calculate the upper tail directly for you. So then you don't need to do the 1 minus thing anymore. So this is an option for you to use if you want. Okay, all right. Exercise. I think I will skip the exercises. I will upload this for now because we are kind of running out of time. I hope we can finish part of the R program. You can work on these exercises by yourself, very simple ones. And percentiles and quantiles or quantile functions. So these are the inverse of the cumulative distribution functions. So by definition, the p percentile is the value that there is probability p of getting a value less than or equal to it. So let's draw a plot to show. For example, let's use normal. So suppose this shaded area is P. then X is called the P's percentile because probability of X is less than or equal to little x is equal to P. Because in any CDF, cumulative distribution function, the left tail probability and the value P and X are 1-to-1 corresponding. Given one, you can find the other one. You can calculate the other one. They are 1-to-1 corresponding. So the CDF is calculated given X, calculate P, right? The quantile function or the percentile function is the inverse of that. Given P, find X. For example, suppose probability of Z is less than little z is 0.66. Namely, Z is the 66th percentile for standard normal. Now, what is the value of Z? In this case, we can use the R function Q norm, feed the left tail probability, and it will return the Z value we are looking for, or it will return Z, 0.4126. So this is also a way that we usually use normal table to do it. And now you see we can use R to calculate it easily using this percentile function. For example, let's see, what is the 99th percentile of X if X follows a normal distribution with mean 100 and standard deviation 15? 99th percentile. If it is 99th percentile, that means the percentile has left tail probability 0.99. And with these two parameters, right? So in R, we can easily calculate it using the Q norm function, right? Q norm. And we want to 99%, so 0.99 is a left tail probability. And mean is 100, standard deviation is 15. Then you can get it. It's about 135 if you round it up to make sure it is 99%. So it's quite convenient to use R to find the percentile. The last one is random numbers. R can help us to generate pseudo-random numbers. It is based on some algorithm, but the performance or the behavior of these random numbers are very similar to real random numbers. And for example, the R norm function can be used to generate random numbers from normal distributions. By default, random standard normal. For example, we generate 5 numbers from standard normal. Just specify 5 here, and 5 numbers here are produced. You also have the option to generate random numbers from other regular normal distributions. For example, with mean 5 and standard deviation 2. It's also possible. Just make sure that don't be confused. The last parameter is the standard deviation, sigma. It's not the variance. It's defined in this way in R. So it's not variance, it's standard deviation. For standard normal, it's not obvious because standard deviation and variance are both equal to 1. But for other normal distributions, they are quite different. Sigma and sigma squared are quite different. So the last argument is the standard deviation, not variance. Okay. If you want to have a reproducible result, for example, I run this R markdown file again, I get the exact same numbers. Then you need to set the random seed. Just use the set.seed function. For example, you set it to be 100. Then if you use the same seed, you run the same code, you get the same set of random numbers. So this is important, especially later on when you're doing machine learning modeling. You want to find the best hyperparameters, and keep adjusting the hyperparameters, and to make sure the comparison is a fair comparison, you need to set the random seed so that each time you split data, you split in the same way, so that the assessment will be fair. You evaluate the model on the same data set, on the same test data set. So for now, it's not that crucial yet because we're just learning the basic stuff. Some resources for R functions. First is click R. You click it, you will see some R functions. Yeah, I have shown you this. So these are the normal, and there are other functions. For example, uniform, Poisson, T, F, chi-square, any distribution. There are 4 items of functions. And also this web page is a professor's web page for a class. Okay, I just borrowed here. So the professor listed some commonly used distributions and the function names for the 4 types of functions. I think it's pretty convenient to use as a reference. Of course, you always can Google it. Just yeah, it's out there. And next, small topic is scripting. I know it's very convenient to just type some code here and get the result immediately. However, this won't be saved. If you want to save your code for future usage, suppose you are doing a project, you should always keep your code, save your code. So that's why it's better to write R script. To create the R script, so when you open RStudio, automatically there is an empty R script here. And in the R script, you can type something. Z is equal to X plus Y. Okay. And after you type anything in the script, nothing will happen because the code haven't been run yet. If you want to run them, you can highlight and click run. Okay. And then highlight the last one, click run. And if you want to see the result, tap Z again. So it will be run. And after that, you can choose to save it. You click the save button, it will prompt you to choose a location, a folder to save your script and give a name to it. So this is the basic R script. But if you only have a very long program of code, you don't need to add a lot of text about its explanation. You can just create a script and save it. And by today, right after a few slides, we will talk about R Markdown. Markdown is an even better or more advanced version of R script because it allows you to write and to show output in the same file in the end, which is very convenient. All right, so this is scripting. All right, and last one is packages. I think it's better to formally learn how to install and how to deal with packages. There are multiple ways to install packages. One way is to type install.packages parentheses quote the package name. So it's somehow like this in our console. Clear console here. So just type install dot packages. So in RStudio, it's very convenient because it will prompt you the right function. And then type the package name, use quote. Okay? For example, if the package is called ABC, and just run it, okay? But don't install it. I don't think there is a package called ABC, okay? And it can also be used to install multiple packages at the same time, but I don't recommend you do that, right? But because it is possible, it is there is an S here. Install the packages. And as I said last time, in RStudio, you can install packages in using this packages tab. Just click it and then click install. And then type the package name. In this case, you don't need quote anymore. Just type the name of it. Right? And also you can update packages. You can attach packages, you can remove packages also. If you think some packages are not useful, and remove them. And you can attach or you can load the package by checking the box. So see, after check this bind box, a line of code is here, is shown here automatically. This means I load the package a bind. If I do this, the second package will be loaded. Of course, this is only kind of good for immediate usage in your R console. Usually, we will load the package in an R script or R Markdown file instead, so that your readers and yourself know in the future that in order to run this chunk, I have to load this library first. Okay. If you just load the library here, it will only work in the workspace. After you quit R and RStudio, the library won't be there anymore. And there's no clue for you and your readers about the package that are loaded. What else? Yeah, to load the package, use library, the library function. All right, so this is the last page of this session. Any questions so far? So far, so good. All right, then let's talk about R Markdown. So in regular semesters, in the fall semester, this is a lab. This is a lab 2. So my TA will teach students how to use R Markdown, how to create R Markdown file. But in the summer, we cannot have labs, so I will explain it to you because it's kind of important. So let's take a look. So R Markdown provides a unified authoring framework for data science. Combine your code, its results, and your prose commentary. You want to explain your results or your observations from your graphical displays. You can put them there. Right? And the R Markdown documents are fully reproducible and support dozens of output formats like HTML, Word, PDF, slideshow, etc. It is very convenient to create your project reports or small essay or presentation, etc. So R Markdown files are used in 3 ways. First, communicating to decision makers, and then collaborating with other data scientists. Okay? Because the results are fully reproducible, you can share the document with your colleague or your teammates, and they can run and add their stuff and share with you again. So it's very easy to collaborate. And last one, it's a modern day. So it's basically it's yeah, because it's reproducible. It's easy to share, to use to teach. For example, all of the lecture slides and notes, syllabus in our class were created using our Markdown. How to get help? So it integrated. So the easiest way is to find the cheat sheets about our Markdown. It's very easy to find them. Open your RStudio, okay? Click Help, and then cheat sheets, and then choose our Markdown cheat sheet. Okay, and click it. You should be directed to the page. Oh, actually, it was downloaded as a PDF file. So this is should be the newest version of our Markdown cheat sheet. Okay. They keep updating it. So 2 pages, a lot of stuff. I suggest you to carefully read each blocks in the cheat sheet because I promise you, you won't waste your time. Right? Otherwise, in the future, when you do your homework using our Markdown, you have some bug you can never, you don't know how to deal with it. And many times they are just in the cheat sheet, but you just ignore it. You didn't pay attention to it. So another way is to go to the website of RStudio, this website, POSIT, resources, cheat sheets. So if you click this link, you will be directed to this page, this web page. So originally it is just called RStudio, and now you can use RStudio. You can use this to code in Python. So they use a new name, right? POSIT. Right? And this page lists all of the cheat sheets for different packages. In our class, we will use a lot of packages actually. So you see our Markdown cheat sheet is here. Okay, this is our Markdown. And if you click this, view the cheat sheet, you will be directed to this page. So this page has some explanations for different blocks in the cheat sheet. Actually, I think it's very good to check that one by one by yourself. And if you want to download it, just click download PDF. You can download the one that I just showed you. Gigantic cheat sheet. So this is the easiest way to seek help. And of course, the cheat sheet is not complete. It cannot contain everything about our Markdown. If you have any specific question, you can Google it. Or if you get an error message, just copy the error message and paste it in Google search bar. You definitely can get some help because this is an open source software. Many people are using it, and many people have the same error message. Turns out that many people have resolved it for you already. So this is the cheat sheet, how to get help. And now let's talk about our Markdown basics. How to create an R Markdown document in RStudio. It's quite simple. Let me show you. So the upper left tab by default is for R script, but you can create an RStudio file. Just click File, New File, and then R Markdown. Okay. And then you can give a title. So this title is not the document name, it's the title in your document, it's your report title. So for example, I can just say it's an example. You can give any name. Author by default is your name and the date. And by default, the output is HTML. You can change it, but just pay attention, avoid using PDF for now. Word and HTML are good, right? But PDF, you probably need to add something else, right? To see. So let's just use HTML. So click OK, then an untitled R Markdown file is here. So as I said, the title you typed is the title of your report, not the name of the file. The name is still untitled too, you see, in my case. And there are something in it, already in it. So these are the contents that is given to you by default. You definitely can change them. They are just kind of examples of, for example, a chunk of R code and markdown text and headers. And this is the global option. Global option. You can change it to global option means the option set here will be in effect in your entire R Markdown file. However, you can change global, you can override the global option in your local option. So in each chunk, you have the option to change this for this chunk, what option you want to do. Okay. For example, this by default, echo equals true. Echo equals true means in the knitted file, the final, the output of this R Markdown file, the R code will be shown to your readers. But if you only want to show the results, you can set it to be false. But this is the default option. You can change it. So this is a global option. And then this part shows you, this is a header, second level header. So by default, usually if you create a presentation like a lecture slides or like something similar to PPT, so this level of header will imply that this is one page of the slide, one slide. Okay, so this is another one. But if you just choose HTML document, it will be a report, something like this. This one is a continuous report with no slides or pages. Okay. I will show you how to create slides a little later. And then let's go back to our studio, and you can change the R code, and you can create a plot. Right. So let's just leave it like this. Let's knit it. Right. So by default, it will knit a report in this format, the default output format. So if I click knit, it will let you choose a location to save your file and the knitted result. So for example, I just call it R exercise. Okay. Then it will start to knit. Sometime. All right. So this is a report. I didn't change anything. I only changed the title. And then you see our code, our output, and plot will be shown all for you. This is a simple example. And you can also, for example, knit it to a Word document. Then you can knit it. So then somewhere. Anyway, um, but I have two screens and my Zoom windows are always covered things in my apps. So this is the Word document. How it looks like. The contents are the same. The formats are slightly different. So they are all options for you to create our Markdown files. Then let's zoom in and take a look at some details in our Markdown. The first text formatting was Markdown. Everything is very, very simple. Basically, if you are familiar with everything that's in this panel, you'll be good. So let me explain it a little bit. If you want to type your characters in italic, then you can use asterisk italic, asterisk. So you use two asterisks to wrap your text. So for example, let me get rid of this and type something I like data science. If I wrap it in asterisk, so let me get rid of everything else so that I can run it quicker. So if I knit it, it's a little bit slow. My computer is very slow. As you see, is italic. Okay. So yeah, so this example shows you how to understand the notes. So if you want to make the letter bold, then use two asterisks to wrap it. For inline code, use tick mark to wrap them. Inline code. You actually can run code in this inline code. And superscript, you use hat to wrap the thing. And for subscript, use tilde. And headings. So this is quite useful for us if we want to create a report for our project or, for example, homework solution. You can use different levels of headers. First level is, you start with £1 sign, and second level 2, third level 3. You can go to even 5 and 6. Right? So it's a good way to organize your result. For example, question 1, you use 2 sharp, 2 pound signs. And then part 1 of question 1, they use 3 pound signs. Next, lists. So bullet points or lists. If you have an ordered list, you can use hyphen. So for example, topic 1, topic 2, etc. So this is the first level. And then for second level, you can click the tab button and topic 1.1, 2, etc. Okay. So you can layer them. You can also use this plus also works. Plus also works. So for unordered bullet points, you can use hyphen or plus or even asterisk. Actually, this one also works. Okay. A, B, C. So this one also works. Okay. You can play with them. For ordered list, you need to use 1, 2, 3, etc. The options are very limited. Okay, actually in our Markdown. So so far I only know how to use one, two. I don't know for different layers of ordered lists. I think only one, two, etc. And next is links and images. If you want to insert a link to your Markdown file, wrap the entire URL in this triangle parentheses or brackets. For example, if I want to insert a website, for example, I want to insert my department's website, this link to my file. I just copy the URL and type the triangle brackets and wrap it in it. Okay. So then change back to HTML. It. See that a link will be shown in the file. See, and it's a clickable. Right? So in your report, you can also insert this kind of thing so that people can be directed to some web pages. So these are bullet points, very basic ones. And then let's go back. Okay. You can optionally add some, give some name to your. Oh, sorry. If you don't want to show the URL, instead you want to create or insert some linked phrase. For example, instead of doing this, I want to say department of statistics. I want to insert this linked phrase. Then I can wrap the phrase in square brackets and put the URL in regular parentheses. Then if we run this, then the native file will have statistics, department of statistics only, but the URL will not be shown. You see, and this is how I insert my any linked phrases in my lecture slides too. So if you click it, you'll be directed to the website. Quite useful. And last one, images. So you just need to give a title of your image and the path to find your image. So this is so this is for local images only. You need to have an exclamation mark. So you need to download the image and then save it in some local folder. And then you can use this syntax to insert the image to your report. Yeah, this is a directory of the image in your local folder. Okay. All right. Any questions so far? I know it's kind of a lot. And the last small topic is not the last. Tables. You have the option to create tables. So in this web page, the cheat sheet web page, see. So you can create pretty tables using some data sets. For example, in the code chunk, you create a data set called data, which is the first 4 rows of a built-in data set in R, which is called faithful. And then you can use this table function in neat-R to make it a professional look table. So let's just run it. Let's just insert it in our Markdown file. Let's see, this is one way to create a table in R Markdown. Oh, by the way, in R Markdown, you can test each code chunk by clicking this arrow. So without generating a whole report, you can test each code chunk one by one by clicking this arrow. And this one means run all the chunks above, because most likely the chunks are related. Okay? Later code may use previous result as their input. So sometimes you have to run all of the chunks above the current chunk and then test the current chunk, right? So this is one way to create a data table. And sometimes you just need to create some text table. In that case, you can just type it. The basic syntax is like this. So first, type the headers. Header of the first column, header of the second column, separate them using a bar. And then this second line is used to specify the structure of the table. Right? So this means you can put any number of hyphens as you like, but theoretically, they determine the width of each column. Right? If you use 3 hyphens for each column, then they should have the same width theoretically, but you can change it. And then starting from the third row, you can type the contents of the cell. So this is a very easy but very raw way of creating a table. Right? So actually, in the web page of our Markdown cheat sheet, there are some more details about it. Right? In particular, can you see? So this is how we create a table. For example, we create a table with 4 columns. Right? So in the second row, if you don't specify column, then you don't put column here, then by default, all of the values are centered, I believe. Right? But you can have the option to make it aligned to the right or left or default or center. Okay. So for example, in this case, this is a result. Okay. So we put column on the right after all the hyphens. Then for this column, values will be aligned to the right. Let's see, this is the result. Right? So usually numbers, it's better to put numbers in this way, right? And left, just put column in here. And then you see the result is like this, right? So for character strings, usually it's better to put it on the left, okay? And then the default, default is left actually, right? And center, you put a column at the beginning and at the end, then it's center. Right. So some details, but I think it's quite still quite useful. Right? And you can also insert equations, mathematical equations into your R Markdown file. Right? You need to wrap equations using these double dollar signs. And the syntax or the rules are the same with LaTeX, L-E-L-I-A-T-E-X, right? The same actually, right? But it does not accept square bracket. It only accepts double dollar sign. Right? Insert an equation. Some more details you can explore by yourself. And lastly, but very important thing, the last important thing is code chunk options. To insert a code chunk in R Markdown, you can click this. You see insert a new code chunk. Then you see an empty code chunk is inserted. Okay. Or if you want to use the keyboard, you can click hold Control, Alt, and I, then you can insert it, a code chunk. It's empty. And then there are some important options for code chunks. First, echo. By default, you see echo is true, right? So our code will be shown to your readers and yourself. If you want to omit your code chunk, just type echo equals false, change it to false. Okay, then only the output will be shown in the report, but the lengthy R code will not be shown. For example, if you want to create a plot using very complicated R code, you want to omit the details, only show the output. And the next one is evaluation, eval, this option. So this one by default is true. That means the current code chunk will be evaluated and executed. However, sometimes you don't want to evaluate a particular code chunk. Then you set it to be false. Okay? Sometimes it's because that you want to show people this is the wrong code, okay? And you don't want R Markdown to run this code, but you want to show it to your readers or to somebody, your students or your classmates. Okay? Then set this. Then R Markdown will skip this R chunk, okay, and go ahead. Okay. Otherwise, if you don't specify this and there is an error in your code chunk, R Markdown cannot run. It will stop running and give you error message. You can never ever get a report at all, result at all. So it will influence all the R chunks below this chunk. Okay. So if there is an error, do this. And next one is error equals. So by default, error equals false. That means whenever there is any error, it will run and it will stop and it will stop running. Okay. If you say error equals true, then it will still run the chunk and print the error message and put in the report. However, the R Markdown file will still be knitted and you will still get the result, provided that later code chunks are not influenced, are not affected by this current one. Okay. If they are all affected, then you need to put error equals true for all the ones below it. Okay. So these are kind of important and useful code chunks for you, especially when you do your homework. Pay attention, they are all available for you. Of course, you always need to set echo equals true because the grader, my TA will grade your R code and the output at the same time. Don't omit your R code. All right. And then, okay, the last one is slide presentations. If you click this link, you will be directed to yeah. Just click it. Yeah. Slide presentations. You have the option to create your own slides. For example, I used this slidey presentation. So in RStudio, you can just change it to slidey presentation. Okay. Then let's for example create another slide. Okay. So each of them will be one slide. So this is one slide. This is a second slide. Okay. And slidey presentation has an advantage that it has no restriction of the size of each slide. Some slides may be longer, some slides may be shorter. It doesn't matter, right? So it's very flexible. It will not cut your content. So that's why I use this format for my slides because, sometimes I have very gigantic code chunks in the slide. I have to squeeze it into one slide. So I use this flexible format. And there are other more pretty formats. For example, ISO slide, this is prettier, right? But it's kind of more restricted. And Beamer presentation, so this one will create PDF presentations. So it's similar to the Beamer, yeah, the LaTeX. You use LaTeX to create slides in PDF. The results, but again, it's very rigid, right? If you have too many lines, too much stuff, it will cut it. it has its own rule. It will cut it. You cannot show the complete thing if you have too many things. So you can play with these by yourself. It's a good way to create presentation for your data science projects. Very flexible. You can directly put some code in your project and put them in your presentation and generate slides. And they are all reproducible. All right, great. We're done with this section. Perfect timing, but we didn't have time to talk about our programming. So I will assign homework today, and it will be due next Tuesday. So our programming will not be covered in homework 1 because we don't have a chance to talk about it. Okay. All right. Any questions? Okay. All right. Then have a good weekend. See you next Monday. Okay. Bye, guys.